Hello and good morning. This is Mrs. Rowe, and this is part of our Learning Biology series from home. And we are in Chapter 5, looking at surface area to volume ratio. I just want to go over a couple of really important key points that you may have missed, or even just to review from last week. So, yesterday during our live class meeting, we talked about the three bacteria shapes, the cocci, the bacillus, and the spirilla, and which one would dry out. Well, this one says, which one would dry out last? I asked you yesterday, which one would dry out first? So which one would dry out last? Which one would lose water the slowest? So which one would have the lowest? Actually, I'm going to do it this way. Which one would have the lowest surface area to volume ratio? Okay, so pay attention. Dry out first, dry out last. What's the question asking? Hint, there might be a quiz that you need to be reviewing these for. So, surface area to volume ratio affects how fast materials move in and out of the cells. It affects diffusion rate, and that's why it matters. Cells are small, size and shape matters. We looked at shape yesterday because all cells are dependent on diffusion rate of molecules. That's why we have enzymes. Reactions need to be fast for life to continue. We need to move materials in. We need to move waste out. Buildup of waste is just as dangerous as not getting enough materials that you need. You saw a video on this agar lab that we normally would have done at school. And the big idea here is if I am calculating for a cube where all sides are the same length, so if it was a rectangle, every face, the surface area is length times width, but I have 1, 2, 3, bottom 4, other side 5, and the back 6 sides. That's where the 6 comes from. 6 length times width, or if they're the same, side times side squared. 6s squared is your formula for surface area. And then length times width times height, or side cube, is your volume formula for a cube. And right away, this tells us if we were to graph this, if we were to look at this, I'm just going to do this over on the side. If I were to look at something that is being squared, it's hard to draw with this, versus, so this would say be x squared, and it's not perfect considering how difficult it is to draw with this, versus x cubed. Okay, the idea is something that is cubed is going to increase at a faster rate than something that's being squared, and that becomes a problem. Down here, it might be that your ratio of surface area, remember this is surface area, this is volume. So what is the ratio of surface area to volume? And you can see as this is your cell size over here. So as your cell gets bigger, the volume, your ratio, as the volume gets bigger, the ratio gets smaller. Because just think about it, surface area divided by volume. The larger the number at the bottom, the smaller the ratio is going to get. Okay, so that's why cells need to stay over here where they're small. If they get too big, this gets too big and the ratio goes down. And what that does is it affects that diffusion rate, or I should say this one here, it affects that diffusion rate, how fast materials can move. So just a quick review for those who need to do this. I'll just do this one here. 1 times 1 is 1 times 6. We have a surface area of 6 if we have a 1 centimeter cell. 1 times 1 times 1 is 1. I saw a common mistake of people doing 3, forgetting to multiply and adding instead. So my ratio here is going to be 6 to 1, which is a pretty good ratio. If I do a 3 centimeter cube, 3 times 3 is 9, times 6 is 54. And this is one of the problems you had to do, so you can also use this to check that worksheet. 3 times 3 is 9, times 3 is 27 for our volume. Now we want to reduce this. We could say 54 to 27, but we want to reduce this down so that this lower number is 1. The easiest way to do that is just divide the top number by the bottom number. Okay, so if I divide 54 by 27, I'm going to get a ratio of 2 to 1 as I divide it and reduce it down. So I can see my ratio is getting smaller as my cell is getting bigger. My cell is getting bigger, my ratio is going down, which looking at this graph makes sense. But diffusion rate, how fast? Well, the molecules themselves are not moving any faster. They simply have more volume to get across, so it's going to take them longer to get across the cell. It's kind of like if I had you race against yourself. If I cloned you so that you and your clone move at the same rate, and I put you out in the hallway and said one of you has to start at one end of the building and run to the halfway point of the hallway, and the other one has to run all the way down to the other end. Who's going to get to their end point first? Well, clearly the person that has the shorter distance is going to get there first. So we say they have a faster diffusion rate because they're getting across the cell faster, even though actually the molecules are moving the same. This doesn't make the molecules themselves move any faster, but they have less volume to get across. And that means the materials are going to get in and out faster. It's a faster delivery. So the big idea here is cells need a large surface area to volume ratio because that means diffusion rate is fast. And there are two ways we talked about this yesterday, you can increase your surface area by folding, by stretching, by flattening, or you can decrease your volume. You can elongate will help decrease volume also. Putting in vacuoles or hollowing out the middle, those are all things that will change your ratio. Okay, so that's the big idea, that surface area to volume ratio is why cells are triggered when they're growing in G1 in interphase. When they reach a certain size, it's actually the stretching of the cell membrane creates a trigger, a signal. It's time for the cell to divide. There's your G1 checkpoint. You're starting to get this trigger that is it time to divide? Is the cell big enough? We don't want it too small because otherwise when they divide, the cells will keep getting smaller. But there's a point where if the cell gets too big, the diffusion rate is going to drop and it's not going to be able to survive. So it needs to divide at just the right time for that cell so that it will be optimal diffusion, but big enough that the two new cells are not going to be too small. And that is why surface area to volume ratios matter. Hope that helps. Until next time.